And we're live. What's up, team? My name is Stan, and I'm here to have a little bit of fun. To go through this problem in section 2.7, and we have a topic of graphical analysis of velocity and acceleration. So I chose to do problem number 58. That looks interesting to me. Now it doesn't deal with the acceleration, but it deals with velocity, average velocity. So let me see if there's anything with acceleration. I don't see any assigned problem with the acceleration. Pretty much there. What is average acceleration? Oh, number 60 is acceleration. Interesting. Well, let's do velocity. So let's do number 58. All right. So before we do number 58, we gotta talk about what velocity really is. So, in simple terms, velocity is position. So you have a little marker here. This is a pretty cool tool, by the way. It's called what is it called? It's a pretty cool tool. But anyways, I'll talk about it later. So what is velocity? Velocity is position of some point x over time of t, right? So when we look at the graph, right? So here we have a graph. Let's say, well, let me just make it nicer. Come on, there you go. Hold on, let's see, draw, and then it pops in. So cool. Ha, there you go. By the way, when I was taking anatomy and physiology, our professor introduced this app to me, and he said it's pretty cool. It's like a whiteboard and pretty cool. You can move objects. Like you can literally look at this and literally cut this out. Let's see. Like you can do this. Hold on. Take a section. Cut it out. Just move it somewhere else. It's pretty cool. All right. Anyways, let's not mess with that. Let's solve the problem. So, what do we have here? Okay. Where's my color? Hello. I don't know. What just happened? I don't have colors. Okay, maybe they'll appear as I draw. All right, so let's draw our graph here. All right. So we have position, right? We said it's position over time. That's our velocity. So we have position, P, right? I could write position, but it's just going to be a mess. So, and time, T. So position of some point X. All right. And position is going to be somewhere. It's going to be calculated in kilometers. In our case, it's a unit of measure, right? And time, of course, is going to be hours. All right. Now, so the velocity of some point X is going to be its position, is going to be the relationship between this position over time. So that's going to be a velocity of this point, right? So let's say we have a point Y. It's going to be the same thing, right? Position over time. This is going to be velocity, right? So the point can be moving from 0 somewhere else, right, in the graph. So it could be here, then it could be here. It could be the same point, by the way, not X, Y. It could be the same point. Same point X is traveling somewhere, right? It could be down here. Now, so the velocity could be 0, could be negative, or it could be positive. So if you remember, from college algebra when we do the graphs, right? So when it goes from left to right, when it's increasing section of the graph, this is going to be positive. When it's decreasing, it's going to be negative. When it's constant, it's going to be zero, right? So zero movement from, so it doesn't go either up or down. It just stays in one spot, right? It goes zero. So now, let's go back to our problem, and let's read our problem together. Problem 58. A person who walks for exercise produces the position time graph given with this problem. A, without doing any calculation, decide which segments of the graph A, B, C, or D indicate positive, negative, and zero average velocities. Calculate the average velocity for each segment to verify your answers to part A. So, looking at this graph, let's go ahead and open up a new page here. So going back to here, right? We're going to open up a new page, go back here, and we know the new file. I don't know what's up with colors. I don't know what they just click. But anyways, probably. So we take a grid. Nice. And we draw a little graph here. Let's try. Just kind of like that. No. All right. So we have position here. Oops. We have time here. Right? And we have graph going somewhat up. Nope, not that. So like that, and then it goes a little bit down. Come on. Something like that. Then it goes up again. And then it goes constant. Something like that, right? So it's close to. We're gonna still look at the graph of the problem, but the picture is close. So this will be A. This will be B. This will be C. This will be D. Now, portion A, right, part A, is asking us to determine where's positive, where's average velocity is positive, where it's negative, where it's constant, right, where it's zero. So from this graph, we see that sections A and C go from 0 to, in our case, they go to 1.25, right? So they go positive up, right? So they go from 0 left to right. The slope is positive. So now A is positive, and this one, C, is positive also. So we'll say from this point, I'm not sure how to pick colors. Let's see. Ah, there you go. There are my colors. Yay. All right, so point. So this one and this one will be positive. Now, what about B? B is going from top to bottom, and the slope is negative, right? So this is going to be negative average velocity, where part D is a constant. So this one is going to be 0. Average velocity of this would be 0, right? Okay, so part A is answered. Now let's confirm it with doing part B. So part B, just do like that, right? So this is going to be part B right here. So B. Or, I don't know, B. Okay, so first we got to determine. So we have position over time. So this is our, if you remember, this is our definition for velocity, position over time. So let's look at the graph in our problem here. Oh, okay. So we have a first section, right? Section A, segment. Let's call it segment, right? It's going from 0 all the way to positive 1.25. So, and then when we look at that point, 1.25, right, and look at the edge of the graph here, and we draw a perpendicular line towards the x-axis, and we see that it falls into x being equal to 0.20, which is 0.2. So let's write down that relation, because that's going to be our average velocity of segment A. So segment A, it's gonna be, right? Segment A is gonna be 1.25 over 0.2. So if we do the math and calculate this, right? I already have this calculated before. So you can plug it into the calculator, or just divide 125 by 2, and then do zeros. So it's going to give you, I'm trying to find it, 62.5. So this guy is 62.5, and our units is kilometers per hour. So this one is done, right? Now B, let's look at B. Section B is going from 1.25 down to 0.50. Now 1.25 minus 0.50 is going to be about 0.75, right? But since the average velocity is negative, we should put the negative sign in there, right? So it's going to be, B is going to be, right, B, negative 0.75, and the time is going to be 0.2, if I'm not mistaken, right? 0.2. Yeah, same, it's going down to 0.2. So 0.2. And if we do the math, it's going to be 37.5 kilometers per hour. Now this is part B. Part C. Let's see what it is. Part C. Part C is going upward from 0.50 to 0.75. So there's going to be 0.25 units, right? Yeah, 0.25. 0.25, and the time is going to be 0.4, right? Right here, if we drop it down, it's going to be 0.4 hours. So, and since this is a positive velocity, right, we'll just put 0.25, we'll divide it by 0.4. And we're gonna get 0.675 kilometers per hour. So this is gonna be our segment C's average velocity, right? Now, finally, D, we probably can predict since it's 0, right? So D is 0, but let's look at the picture where it's 0. 0.8, Yeah, so it doesn't anything divided by zero is zero. Sorry, zero divided by anything is zero. So there's actually no calculation needed. You can right away say that d is going to be 0 kilometers per hour. So thus it confirms. So if we look back on this graph right here, it confirms that first one is positive. So this guy is positive. This guy is going to be negative. This guy's going to be negative, and I wrote positive for some reason. Whoops, equals to negative, right? Part C is also positive, and part D is constant, 0. So, yep, that's the solution, guys. If you have any questions, comments, feel free to drop them in the section, in the comment section if there is such thing. And thank you guys for watching. Hopefully this helps to learn new material. I was thinking about acceleration problem. Maybe somebody else will do acceleration problem and explain it. But I chose to do velocity, average velocity. Thank you guys, and see you soon.